On the table are 4 cards. Every one of these cards has a number on one side and a letter on the other. Now, I'm going to tell you a rule, and it may be true, and it may be false. If a card has an A on one side, then there must be a 3 on the other. In a moment, I'd like you to determine which cards, and only which cards, you need to flip over to determine whether the rule is true or false. In other words, the least amount of cards you need to flip over. You can pause the video to make your decision, but you don't have to respond. You can keep it to yourself. You may make your decision now. Okay, very good. Most people will either answer A only or A and 3. To reiterate, the rule says that if a card has an A on one side, then there must be a 3 on the other. So it makes sense to flip over the A to see if there's a 3 on the back. A missing 3 would automatically prove the rule to be false, but flipping over the 3 actually tells us nothing, since the rule doesn't say that 3s have to have A's, just that A's have to have 3s. If the 3 card has an A on the reverse, it goes along with the rule, but having any other letter doesn't prove or disprove the rule. Very few people choose the 7. But if the 7 has an A on the other side, it automatically disproves the rule. So the correct answer is A and 7. If you got it wrong, don't beat yourself up. The human brain is hardwired to look for evidence that confirms our suspicions, which is the reason that so few people turn over 7. Turning over A and 3 are ways of confirming the hypothesis, which is what most of us want to do. They want to see if A has a 3 and if 3 has an A. They don't think of seeing if there is a card with a number other than 3 that has an A on the reverse, which would disprove the rule.
The human brain is hardwired to err on the side of false positives rather than false negatives, and this is probably true of all animals. That rustling in the bushes as the caveman stands on the African plain could be a lioness looking at you as a potential meal to take back to her pride. It could also be a harmless bush rat or even the wind. However, our hypothesis that it's a lioness holds more weight in our minds. In a way, it's sort of like the caveman version of Pascal's wager. If we run, believing it to be a lioness, and we're wrong, no harm done. We were never in any real danger to begin with, and we got a little bit of exercise. If we were right, then we've averted a calamity and survived to run another day. However, if we decide to disprove our hypothesis by checking the bushes, and find out we're wrong, we've lost nothing, but gained nothing either. The wind is, of course, useless to us. And a bush rat, while it may make a good meal, will likely run away before we get a chance to catch it. Now, if we investigate it, and it turns out that our hypothesis was right, we're lunch. In evolutionary terms, this propensity for false positive is advantageous, for obvious reasons. But in today's modern culture, with our technological advances, we find little practicality to this behavior. The good news is that if we know about this bias, we can consciously look for ways to try and disprove our preconceived notions. A good way to start is to ask yourself, could I be wrong? And look for evidence that goes against your preconceived notions. This is the definition of open-mindedness, and it's the basis for a skeptical worldview.